Hello everyone, welcome back to week 6 stream processing. In this video, we are basically going to talk about schema registries. We're going to explore the concept of what happens if the producer and the consumer are not speaking the same language. What happens if the producers are producing a particular format and then they change the format? Who's governing all this? And why is this such an important topic? So let's talk about schemas. Generally, when we are using Kafka, we have a producer, we have multiple consumers, and then they are basically exchanging message between each other. But what happens if the producer today is speaking English, but then if he or she changes to French? In that case, the consumers would not be able to understand that. The same can happen if you change the type of the message you're producing. So let's assume you are producing a JSON in which one of the fields is called vendor ID in our example. Currently, we have used vendor ID as a string, but what happens if you want to use it as an integer? If that happens on the producer side, that breaks the consumers. And what happens to the complete flow? Let's assume somebody is consuming all the data from the earliest state, which was, let's say, 7 days ago, to now. How will that happen? And in all these cases, this would be a huge issue. Schemas also kind of like prevents us to make mistakable changes. So I have seen people putting PHP objects or complete Java serialized objects into Kafka as a topic, and that should not be the case, right? Either you should be producing a JSON or some sort of formatted string so that the other person can easily understand that, and if they are not in the world of PHP or Java, they can still read it. So how is that done? That's done basically using schemas. Schemas are nothing but basically a contract between the producer and the consumer. So let's see how it starts. The producer makes the schema because the producer knows like what kind of data they have, so they can generate a schema accordingly. And then this schema is basically distributed to the consumers. When consumers and producers both have the same schema or compatible schema, which we're going to talk about later, they can basically read each other and understand each other. It's basically giving them both a dictionary to encode and decode their messages without actually even knowing about each other. And that's fantastic, right? Because today you want to maybe produce a message which is consumed by two consumers, but your topic can get really famous in the company, and then hundreds and thousands of consumers are consuming from you. It would be impossible for you to make changes while being compatible with all these consumers, or to make changes in such a way that you can enhance and you can do the evolution of your data, but it not break any of the consumers. Currently, a lot of companies do struggle doing that. And an obvious and easy solution is to use something like a schema. As I said, schemas are nothing but contracts in which the producers says that I declare to produce messages to Kafka using the schemas defined. And you can have multiple schemas. They just have to be compatible with each other. That's why it says using schemas defined. But who's responsible for making all this possible? Who's responsible for saying, hey, you know what, this schema is wrong, or this schema is not compatible, or the new schema you are producing to or doing an evolution of is not compatible with what previous schemas were, and how do we control all that? And for that, there is something which is called schema registry. It's provided by Confluent. It's also available open source, so you can choose. And basically, the schema registry kind of controls this movement between producers and consumers and between schema compatibility. So all these schemas are basically going to schema registry, and then schema registry is kind of like taking care of compatibility and all that. So let's take a look, how does it actually happen in our producer consumer example. So right now, till now, we had producers which produced to a topic, let's say topic 1 in this case, and we had a consumer who was consuming from this topic. Now comes schema registry. So what happens in schema registry? The producer first publishes its schema to the schema registry and say, hey, you know what, this is my schema. This is the kind of message I want to produce. This is the kind of contract or dictionary I want to give it to you so that anybody in future can decode this message. The schema registry would give an acknowledgement. So if this is the first time you are producing to your topic, there would basically be no schema. So this would be your version 0 or version 1 of the schema. And then the schema registry would say, hey, you know what, all good, perfect, go ahead and produce your message. But it can happen that this was an old topic and you are a producer who's trying to do some evolution on top of it. You create a new schema and you give that schema to schema registry. In this case, the schema registry can say, hey, you know what, wait, you cannot produce with this particular schema because this is not compatible. And the compatibility rules are also defined in the schema registry. So it can say, hey, you know what, this is not good. I don't think so. You can produce it with this. And the acknowledgement which will be coming back would be basically, hey, you know what, sorry, you cannot produce with this particular schema until you are using the compatibility values you are using right now. And the producer would not be able to produce in that case. The library, Kafka library, which we are using, would just throw an exception in that case and will say, hey, you know what, sorry, the schemas are not compatible, so you cannot go ahead. But let's take the happy path right now. The happy path is basically you produce a schema, the schema is compatible, or there is a new topic, the schema is new, and the acknowledgement you receive is that everything is good. Please go ahead and you can publish your message. In that case, you will basically publish your message to the topic, and the consumers can now consume from the topic. But where will the consumer get the information or the dictionary I was talking about to consume from, right? So in this case, they will basically go to schema registry and read their schemas. Let's say the producer one was producing with schema version 0. There is always obviously an ID in front, which is returned by the schema registry. That ID kind of helps identifying which particular schema to read from. But the consumers can also decide to read from a different schema or a different version of the schema, not a different schema, but a different version of the schema. So it can actually happen that a producer is producing with version 3, but at the same time, your consumer is consuming from version 2. And that's only possible because version 2 and version 3 are compatible with each other. If the compatibility case doesn't make sense, don't worry, we have more slides on that. And we are also going to see an example in which we actually see this exception happening. But for now, every time a producer is producing a message, it will use a schema and the acknowledgement will come. If the acknowledgement is successful, it will go ahead and the consumer will consume it. In our previous examples, we were using JSON all the time. But now we are going to see how we use compatible schema types, which is basically Avro, and we can also do protobuf, but our examples are with Avro. And I think Avro is also the most famous one currently being used in production systems. So Avro is nothing but a data serialization format. It's open source, and it was generated for big data technologies like map reduce time, basically to make consumers and producers or producers and consumers compatible with each other without actually having any communication layer between them. Or Avro is being the communication layer between them. The good part of Avro is that the schema you define is still like a JSON format, so it's very easy to read. But at the same time, the data is in binary format, so it's really, really efficient in comparison to JSON or other technologies. But Avro does fit the bill for us when it comes to Kafka, because Avro provides a lot of features. Like let's start from the very beginning, schema evolution. There are a lot of JSON libraries. It's splittable, so you can have like nested Avro, so you can generate multiple Avro files and then just include them into different Avro versions. And then there is versioning, there is code generation, which you will see. There is compression. It's called transparent compression, but it's basically compression. There is no manually assigned ID field, so it doesn't work with the field ID of the field, but it actually works with the name of the field. It's a rich data structure type. You can have long, you can have timestamp, you can have date time, and I think UUID is also there. So enums are also there. So there are a lot of data structures which are already inbuilt into Avro. There is unmarked data. There is some sort of called dynamic typing and all that. So Avro fits the bill perfectly when it comes to Kafka. And I will highly encourage you to use Avro as a default way to go. Some companies are also using protobuf. but I think Avro is a bit more mature when it comes to Kafka and the compatibility between them. Talking about compatibilities. Kafka or in schema evolution, we need to think about three different kind of compatibilities which we can provide, which we can say, hey, you know what, it's forward compatible, it's backward compatible, or it's fully compatible, right? So the forward compatible means that the producers can write with a version 2 or a updated version, and the consumers can still keep consuming from version 1. That will be the case in which you can add a field, but it's optional, right? So the consumers will still keep consuming, will not care about the new field which you just added, and also because it's optional, it's kind of compatible. The backward compatibility means that the producers can keep producing with version 1, but the consumers can consume from version 2. I think the same example which we gave last time of an optional field will work here, because the optional field will allow V to take the option as a parameter, rather than actually causing an error at that time. And then there is this mixed version kind of thing in which or I will call this full compatible. And then this basically any producers can produce from any version, and the consumers are consuming from different versions, and everything is basically fully compatible with each other. So if you produce with 23, the version 19 consumer can read it. If you produce with version 21, still the consumer with version 22 can read it, and so on. So it's basically fully compatible, and you can do whatever you feel like. Now let's take a look into the code itself. Okay. So what I did, I already created our rides AV.sc file, which is basically an Avro file. And how do we define it? We define it using a type, and we need to specify the type for our Avro file. And the type is basically a record because it's multiple, right? So then I define a name, which is basically my ride records. Then I have a namespace, which is called schema registry. And then there are fields inside it, right? So that's why it's a record. And the field is basically vendor ID, which we all are very familiar with. Passenger count. Let me do vendor ID. Passenger count, trip distance, PU location ID, or let's remove PU location ID for now. Let's just do it with vendor ID, passenger count, and trip distance, right? Let's first look at this. So let's first create a topic itself. So let's go to Confluent Cloud. So let's go to Confluent Cloud, and there we can basically create a new topic, which would be our rides Avro topic for now. Again, I'm gonna just partition it to 2, and the retention I will say is for 1 day. Save and create. I don't need a data connector. And as you can see, there is basically no data and there is no schema attached to the data itself. So what I did right now is basically I copy pasted the JSON producer we had. I renamed it to Avro producer. These are all the properties which were already there. So I had to change this to Kafka Avro serializer, and then basically add some more information for the schema registry itself. These keys are basically found. These keys are basically found from your schema registry. So you need to create a schema registry key, and this is the username and this is the key basically. To make it easy, what we can do is we can actually do schema registry key is equal to then basically we can just, so it becomes easier for you guys to later on change basically in your code itself. So the earlier case was just going through the CSV file and creating a rights. So now we will create a write record. So it was earlier like write, but now we will create the write record, which is basically this. But even before that, we need to kind of change a few things. What we need to do is basically we have created the schema, and if you see in our build.gradle file, we have actually added a plugin. So this plugin helps us generate the class for our schema registry. So what I will do is basically I will just clean everything for now, w clean, and you can note these commands when you kind of like, I'm gonna check in the file in the Git repository so that it's easy. But if you change the Avro file, you might want to run this commands again. So I just cleaned everything, and then I can say build, and here we go. Now we should be able to see write records. So now we have our write records, and this is an auto-generated file. So basically, I didn't do anything here. It was just coming from the command itself. As you can see, it's a lot of data there, and you really don't want to do that. You just want the file to be generated for you. So that's why I'm using this plugin, and you can just use the commands gradle w clean and build. So that's basically how we generate a file or generate a class from the writes file. And now what I'm going to do is I'm going to generate our writes record. So instead of write, I'm going to generate a write record, which is nothing but a specific record base. And this is coming from the Avro world. So what we can do now is, so what we have readers, readers dot, can we do, so read all stream dot map. And in the map, we now have our row, right? So the row is nothing but an array. And what we can do here is basically say, so write record dot new builder dot, so what we wanted set vendor ID. So we want a vendor ID, and I'm gonna basically go here, take a look in, let's split right. So now I'm going to take a look into what my vendor ID was. My vendor ID was AAR0. So I'm just going to paste here, and I will, instead of AAR, I will say row. And then I needed to set trip distance. Trip distance is nothing but my fourth value or my fifth value in the row. So I'm going to just do this, then set passenger count, which basically is this one. So, and I think that's it. So this builds my write record, and I think I need a dot build. So this build will actually build it. And then I need to collect into a list, and I can then put it on here. So this would give me my list of write records, which I was looking for. I can close this. And then I need to publish this, right? So now I have my write records. Let's rename this to write records. And you can obviously name the file a bit different. You can say write Avro records or whatever. And then here also we will be having write records. And obviously we are using a Kafka producer, which is producing using write records. So we just need to change a few things here. And obviously it doesn't have a PO location, but it does have a vendor ID. So we will say get vendor ID. The write is the write record, and I think everything else stays the same. So let's try to run this. Oh, maybe not. Wait. We needed to change to writes Avro. Did we? Yeah, we already did that. So we already put the topic name as writes Avro. So let's try it one more time. Let's see, it's producing some messages. That's good. Let's take a look if we have something here. And we can see that we have vendor ID, passenger count, and trip distance. If we look at the key is still a string because we are not using an Avro in this case. But we can also look at the schemas here, and we can see that the namespace is schema registry. there are fields, and these fields are basically coming from our schema registry itself. We can also take a look at the schema registry directly in the environments, and we can see how the schema registry is defined. And we have all the values here. So you can also do something, compare versions, download, duplicate, and all that stuff, compatibility settings. So this is interesting. So that's what I was saying. You can change the compatibility settings. I would like to be transitive-full. So this would give me the complete lockdown in my schema evolution. But this is really good because in the end of the day, you are, as a producer, your main job is that your consumers can consume from your topic, right? It's your job is not to just produce messages. It's to give value to the consumer. And transitive full will actually allow the full compatibility which you are looking for. And in that case, you would not be able to do anything wrong with your schema. So I save it like that, and I can actually go back to my topic and see what's going on there. Yeah, I think all the messages are just coming in, and all of them are basically the same format, and we have the schema, right? So that's nice to see. But what happens if we kind of like change our evolution in a wrong way? So I already created some files for you, but I'm going to edit it right now. The reason I'm created it is because I would like to check in the code like this so everybody can see it and then play around with the schema itself, because we cannot change the name and the namespace anymore, because then it will be incompatible, right? So we need to keep this fixed. But let's do one thing. Let's try to do an int here, right? This makes it incompatible because if I am assuming the vendor ID to be a string, I'm kind of decoding it in a particular way, right? And now if I decode it in a different way, this would be then like, you cannot decode int and string together. Theoretically you can, but you would need to know what's going on. And let's do this. So let's do Gradle clean build. Let's run this, and there is a failure. Yeah, okay. So it already I think it builds, but it complains after that. So let's look at write records. Let's look at vendor ID, and we can already see that it's been updated to int from string, right? So actually the build failed because it compiled it and then it said, hey, you know what? I cannot really decode this as a row. So now the row is in string, so we can just do an integer dot parse int. And this should work because most of our vendor IDs are basically integer values, as we have seen. I think we can already see that. Maybe if we do set 10, we can see that the vendor ID is 2. In this case, the vendor ID is again 2, 2. So in all these cases, it's 2, but we can already see that the vendor ID is convertible to integer. So let's try to do that. And this can happen a lot of time, right? Like sometimes you decode the CSV in a particular way that you thought it would be a string, but it was actually an integer, or you are decoding it as an integer because the first 2000 lines were in int. And later on, like, I don't know, 5 days later, you realize that, hey, you know what, this values can only be string. They cannot be int because the schema is like that. And you just generated the schema from the CSV. All right, so let's try this. Now it failed. So it did not allow me to produce any messages, but it just threw an exception which said invalid configuration exception. So the schema being registered is incompatible with an earlier schema of the same rides avro value topic. So rides avro topic, and value is basically the key value pair. So this would not allow us to produce, and that's good. So let's revert our code here. And basically go here, revert this also, so it's a string. So let's try to do a compatible change instead rather than an incompatible change. So we already know that we have other topics which we can use. So we have PU location ID, which is one of our favorite ones. So let's try to use that. So let's say the name is PU location ID. The type, this is now tricky part. So the type is basically, it's a default type, right? So it's null, and the null has to come in front, or it's basically a long type. So let's say long, and then the default is basically null. This is a bit special in Avro that you need to have these quotes here, but then not have quotes here. So just so that you are aware. So let's try to do this. Let's go back to our Avro. I think what we need to do is create a clean build. And now this error should go away. Yes, our vendor ID is basically again a string. But we also have one more thing now. So we have set PU location ID. We can again go to our rights.json and just copy paste this part. And we just say row here. So the row location, and then hopefully this is compatible. Let's see. So we run this, and we can see that some data is being produced. And that's good. And we can just refresh this page. And we can see the new data is coming in with the PU location ID also this time, right? And we can check the schemas. The schema has been updated. Now there is another field, which is one of either a null or a long. So now this is basically compatible. Let's go to our schema registry and just check it out one more time. We can see that there are 4 versions, and I think these 4 are because I was trying before. So maybe you would see only version 1 and 2. And we can also compare between versions. So turn on version diff, and then basically you can see from version 4 to version 3. I think there was some bug in the UI, and you can see that these were basically added. Actually, I should do version 3 to version 4, and we now can see that these things were basically added in our new version. So now you can keep making this more compatible. You can keep changing this, but you will never break your consumers downstream. If your consumers really need the PU location ID, all they need to do is to just update to the new schema version. But you don't really have to go and tell them, hey, you know what, I'm adding a PU location ID, so now you cannot consume anymore. You need to upgrade your application before you consume the data from the topic. And this is really important. These kind of evolution are not fun to do when it's in the batch processing world, because it's still batch. You might fail once, somebody will take a look into it and maybe fix it. It's not ideal, but it's not the end of the world. But let's assume you are building a streaming application which is user facing, and something like this happens and you cannot consume from the data anymore. That basically means your clients or your actual users cannot see any data coming in or cannot use your application altogether. And that's actually a big loss. With the world going towards streaming, the world taking higher strides with more data as a solution, there is a need for having schemas and having this contracts between producers and consumers, so that accidentally also nobody is breaking any schemas. We just finished the schema evolution part, and what I showed you was producing messages to Kafka. You can use the same logic to consume messages also from Kafka in Avro format, right? So I'm not showing this as an example, and I think I will not even be able to have the time to build that example altogether. But please feel free to try that. It should not be that hard. Just try to start from the JSON consumer and just try to change that using the rights record which you already had. So there should not be any issues when you're consuming using Avro. Just need to change a few variables here and there. And this also is applicable to our Kafka streams. Please do try it as an example. I've already built a CERT and I will check in the code after this, which will allow you to basically consume using Kafka streams. We have discussed a lot in these videos. We have discussed the basics of Kafka. We went into some of the configuration details and how Kafka is clustered and everything. We then looked at some examples using Java and JSON files. We continued looking into Kafka stream application, what is windowing, how is windowing done, and then in the end, to wrap everything up, we looked into KSQL DB, Kafka Connect, and Avro schemas or schema registry. I hope you learned a lot from this. I am going to build some more videos for the Python folks and maybe use PySpark as an example. But for now, if you are in the Java world, this is the end of it. I hope you learned a lot from it, and you can apply this knowledge directly in your production systems, in your workplace or in your private life. I'm very happy to listen to feedback and to improve this course. So please do send me your feedback, and if something is not clear, feel free to put that in the chat directly to me or in the Course Data Engineering 2023 group. And if you find the answer, please do update the FAQs as well. But that's it. Thank you so much for being here. I really appreciate it. I wish you learned a lot from it and you gained a lot of value out of this course. Bye.